In this video, we're going to talk about the addition reaction of the word alkene. Now, I'm going to define what is addition reaction. They're going to look at what's electrophile and nucleophile. I'm going to give the definition and the various examples. Then we are going to look at the various type of addition reaction and their what example. I'm going to explain step by step. Then by the end of this video, now I'm going to give you ways and patterns. I will see questions in the exam. So make sure you stick to the end of the video. Take everything single thing down with your notebook and your pen. And if you have any question, always leave it at the comment section. I will respond to that. So let's get started. Now let's start this video with what? Addition reaction. Addition reaction is a type of organic reaction whereby small molecules or atoms are added to what? To the multiple bond to form a single bond. You get? So it means that in addition reaction, you add what? Small atoms or group to break the pi bond. You get? Now, unsaturated compounds are really converted to what? To saturated what? Compound. So this is one thing you want to know about what addition reaction. And before addition reaction takes place, there must be two things in the reaction. One, you must have what we call the electrophile. Then two, you must have what is called the what? Nucleophile. Now, if these two things are not present in one reaction, there's no way that addition reaction will take place. So you ask yourself, what is electrophile? Electrophile, these are electron-loving species, or they are electron-seeking species. Because say they are electron deficient. So in any reaction, those species that need electron, they are called electrophile. You get? Example of this one here. These are example of what? Electrophile. Now mainly you see that as well positive, but we also have the neutral one with your CO2, then a CO3, BF3, F2, Cl2, or BO2. These are example of what? Electrophiles. You get? The next you want to look at is what? Is nucleophile. What is nucleophile? These are electron-rich species. They always have pair of electron to donate. You get? So in any addition reaction, those species that will donate electron or give out electron or have pair of electron to donate are called what? Nucleophile. Do you get that? So in addition reaction, electron always flow from what? Nucleophile to the what? Electrophile. You get? Example of this nucleophile are this one say just seen here. We have various one of them. You get? Now, these are what the negative sign. Usually, the way you can easily know electrophile is through the what? Negative what? Sign. You get? Now, these are neutral. Water is what? Is what? Is a nucleophile. CO3 is what? Is a nucleophile. The other thing you want to understand is that all unsaturated compounds are what? Nucleophile, because they have the pair of electron to give out. You get? So there are stuff you really want to understand. So in summary, in addition reaction, there will be what electrophile and what? Nucleophile. So electron move forward from the electron-rich species, which is what? Nucleophile, to the what? Electron-deficient species, which is what? Electrophile, before what a reaction can what? Occur. So now let me show you what format in which you are going to see addition what? Reaction. So now let me show you example or the format of what? Addition what? Reaction. Now this one is an alkene, right? So here we have CH2 double bond CH2. Now this double bond contains what? Sigma bond and what? Pi bond. So there are always two bonds here, sigma and what? Pi. So now when addition reaction takes place, it only what? Breaks what? This pi bond. You get? Now what you want to do here is that now when you add this one to the multiple bonds, we will convert it to a single bond. Now this guy can also be written as CH double bond HH. You get? So now when you add this one here, X2, right? You can see that now so here I can say what? Here is what is the nucleophile. Nucleophiles. Now this one will be the what? The electrophile. Okay, electrophile. Then this one what? Be a catalyst or a catalyst. You get? Now the reason why you need a catalyst in addition reaction addition reaction is always what slow. You get, unlike what the inorganic what reaction. So you need a catalyst to what actually what power what that what reaction. So most of the organic reaction you're going to see, especially what the addition reaction. Now you see reagents now or catalysts or something you add to the reaction to what speed up what the rate of what reaction. In some reaction, if there's no catalyst, the reaction will not occur. You get, so you really need to what now in addition reaction or any addition reaction you're going to see, you need to what take note of the nucleophile, then the electrophile you're adding. Then this one is very very important here. You get, now this one here can also be X. You get, so when this one, remember this X can be any what any of the electrophile or anything you are adding to it. You get, depending on what the type of addition reaction you're looking at. So if you are not adding this stuff here, now what you want to put in mind is that one of them will be added here, one of them will be added here to break what the pi bond. Now these two carbon atoms are still connected together. So here I want to have HC. Here we have H here, single bond. You get that? So what will happen here? Because we are adding these two, one will be added here, one will be added here. The pi bond will not be there again. So here we have X and what? Here we now have X. So when you add this one to this one here, this is what you are going to get. Now, one thing you want to look at is that you must know the name of this guy, you must know the name of this one, must also know the name of this one here. Now, more especially, the name of the product is will always be give. Now, you always want to give the name of the word product, which is what the final answer you get. So now this is just a brief introduction to what to addition reaction. So the next we're going to look at what is the various type of addition reaction in which what alkene what undergo. Now let's get into it. So the first type of reaction of alkene you really want to know is what is the addition is what hydrogenation what reaction. Hydrogenation reaction is what the simplest addition reaction of what of the alkene. So what is the hydrogenation reaction? It's the addition of what hydrogen in the presence of what? In the presence of nickel, platinum, or palladium what catalyst. You get to form what to form the alkene. For example, when you have something like this, CH2 double bond here, CH2 plus what? H2, which is what the hydrogen. What happens here? You need what a nickel catalyst or what platinum catalyst or what palladium. You get that? So any of these catalysts will what make the reaction to what occur. So now, what would that be the product? One of the hydrogen will be added here. One of the hydrogen will be added here to break what the pi bond. So the product is now going to be CH3 double bond here, CH3. So this is what is the reaction. Very easy. So it's just like hydrogen, then multiple bond here, hydrogen. Remember, I tell you that this one is what is the pi bond. One is what break the pi bond. So when you add two of the hydrogen, so one will be added here, one will be added here. So here we have, now it can either be any of this one here, so you can just say platinum, no palladium, or platinum or nickel. So what are we going to get is this one here, H. You get, so now here we have what the ethene, here we have the what hydrogen, here we have what the palladium catalyst, here we have what ethane. You get, so we are going to look at another one here. So now let's look at what the first example here. Now when this compound here, which was 2-butene, we have what hydrogen. At what catalyst will produce a product here? You get, remember this is called what hydrogenation of what of the alkene. So it means that now the catalyst can either be a platinum catalyst, a nickel, or a palladium. So you can either put anything there. So now let's say nickel catalyst. So when 2-butene react what hydrogen with what nickel catalyst, what will be the product here? Which is what A. So one of the hydrogen will be added here. One of the hydrogen will be added here. What you are going to form? What you are going to form? Here we have CH3, about CH3. You get? So now for every product you give, you must give what name. So what is the name of this guy here? Here you're going to be what? Butane. So in hydrogenation reaction, the alkene are only converted to what? To alkane. So that's why you have the butene, which is 2 butene, is converted to what? Butane. You get, so you need to take note of that. In some cases, now these are, you are going to see it. You get, these are going to see it. CH3. It's okay. So in some cases, this is how you are going to see it here. It also shows what the hydrogenation. That is, alkene will undergo what? Hydrogenation, the process of nickel catalyst to produce this product here. You get. So hydrogenation of the alkene is what the simplest one. You need to what? Take note of it. You get. Let's move to the next one. So the next reaction we are going to look at is what? Halogenation of what? Of the alkene. So this is when you add halogens to the alkene to form what? Alkyl halide. You get. So for example, here we have CH2 double bond CH2. Now plus, now you can choose any of the halide Cl2. Now these are always occur in a medium. You get the medium in which one it undergo CCl4. You get. Now this medium does not affect the reaction. You get. Do you know the reason why? This one itself is what is a nucleophile. Now this one says what is electrophile. Right there. So when you're adding, this one does not play any role. At times you might even ignore it. Or like the first one we have done, that we have what nickel catalyst. You get. So in the what halogenation reaction, chlorine, one of the chlorine will be added here, one of the chlorine will be added here, just like the way we added what? Hydrogen, 2 hydrogen. So here we have CH2 Cl, CH2 Cl. You get. So this is now what the reaction. So we're going to do 1,2 dichloro what? Ethane. You get. This is called alkyl what? Halide. This is called ethene. You get. So this is a typical example of what? Halogenation what? Reaction. Now let's look at another one. So now let's look at this one here. Now, fair for what is the name of this guy? Now this guy is called what? 1, 2, 3, 4, 1 butene. Here we have what? Bromine. It's okay. Now the thing is that now one of the bromine will be added here. Remember this one is bromine gas, right? So one of the bromine will be added here. One of the bromine will be added here. You get. So here I have CH3. Here we have what? CH2. Here we have CH single bond CH what? 2. So here we have B arrow. Here we have what? B what arrow. You get. So we're going to do what? 1,2 dichloro what? Butene. 1, 2 dibromo what? Butane. So that is what the stuff here. So in the exam, this I will sit. Here we have CH3 CH2C. You get. Now you may see it like this, or you may see it like this. You can say, let me see it like this: A plus what? B arrow 2. Here we have CH3 CH2 CH. So in the exam, please look at something here. In the exam, you can either see it in this format, or you want to see it in this format. You get. Yeah, they're asking you what is what product of what of the reaction. When this guy here, 1 butene, react with what? Bromine gas. What is the product? You get. Or is that which of the alkene will react with bromine gas to produce what? This what reaction. So you need to be conversant with this reaction. Now for you to answer this question. You get. So these are the various ways now you see what the question, right? So this one here we react this one here to produce this one reaction. Now from this one here, which of the alkene will produce this one and the product when it undergoes hydrogenation or reaction when you have bromine gas? It means that the double bond is in between these two carbon atoms, kind of the two bromine. You get? So it means that this one is going to be this guy. Okay, so this is one thing you really want to understand. You really want to what? Master what? The reaction, so that no matter the format the question will come, you'll be able to what? To answer them, right? So this is it.